All right, we're going to start on our next lesson, 4.5. Welcome, 8th grade students. I'm so glad to have you back. We just completed our first full week of flipping the classroom, and now we're starting on 4.5 and going to finish the chapter doing the same thing. So I definitely want you interacting in the videos, taking notes, and be very thorough in your note taking, as thorough as I am in giving you the notes. All right, our objective today, we are going to identify, write, and graph direct variations. And so you're probably wondering, what in the world is direct variation and how does it fit into what we've been studying? We've been studying linear equations and we've been studying slope. So this is a little bit of a tie-in, another concept to kind of focus in on. All right, so let's look at our definitions here. A direct variation is a special type of linear relationship. So it's still a straight line, but it's written in the form y equals kx. It's linear, it's a straight line, and that straight line always goes through the origin. Always, 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 always. And we call the k in this particular equation the constant of variation. But it definitely means slope. It ties in and does mean the slope of the line. So let's look at example 1. And in this particular example, we're going to identify direct variations from equations. And I've got 3 of them here for you to look at. We're going to tell whether each equation represents a direct variation. And if it does, we're going to identify the constant of variation. So let's go ahead and get started with letter A. Y equals 4x. Now, the first thing I want you to notice is that, does it look like y equals kx? Is it in the same format as that direct variation equation? And hopefully you're thinking to yourself, why, yes, it does. So this is definitely a yes. This is a direct variation. dv means direct variation. And so, looking at the equation, can you tell from the equation what k is equal to? All right, if you are thinking 4, you are exactly correct. So, good job. When it's already solved for y, see if it's in the format y equals kx. Great job. Now, let's look at letter B. Okay, this time our equation is negative 3x plus 5y equals 0. Okay. It's not solved for y, but we can solve it for y and see if it's in the format. So we're going to put our force field up, so protect that 5y. Don't move it, don't touch anything with the 5 or the y just yet. We want to move negative 3x over to the other side. So if you said, hey, let's add 3x to each side, you are correct. Okay, now 0 plus 3x is 3x. And then last step, get y by itself, divide each side by 5. And you've got y equals 3/5 x. Now that y is solved for, is it in the format or similar to y equals k times x? Do you see how it matches up? Y is on top of the y, equals on top of the equals, k on top of the 3/5, x on top of the x. Do you see how it all lines up? So could you go ahead and kind of summarize this and go, hey, I think this is direct variation, and you would be correct. It is a direct variation, even though it was originally in kind of a standard form. You could rearrange it and so that you could see y equals kx very clearly. And so in this particular example, what would be the constant of variation? If you said 3/5, you're correct. Or if that's what you wrote down. Great job. I'm sorry, I'm kind of squishing it in. I write too big. You keep writing down the page. You have plenty of white space to keep writing down the page. All right, let's get to letter C, our very last one here. 2x plus y equals 10. It's not solved for y. That's okay. We can get y by itself. So that's our goal. Get that y all by its little lonesome. So we will take away the 2x. And now we have y equals negative 2x plus 10. Now let's match it up. Is it in the format y equals kx? Now, I see kind of an extra thing hanging off the end here. Do you see that part, that plus 10 that's hanging off the end? That shouldn't be there if it's a direct variation. And so we would say no to this one. This is one where we would definitely say that's not a direct variation. There's an extra constant number that's added to the back end of x, and that's what makes it not a direct variation. So in letter A, do you notice that there's no number at the back end? It's 4x basically or essentially plus 0. And see in letter B how our equation is set equal to 0, that our constant number is a 0 already here. And then in C, they gave us that constant number 10. So one hint that you could take, and if you want to write this towards the bottom of your page, because I have no space left to write this for you without making it too blobby, is that if you have an equation that's in standard form, like B and C, if your standard form is set equal to 0, it's a direct variation because we want that constant to be 0. If your standard form is set equal to any other number other than 0, like in letter C, it was set equal to 10, you're going to have a constant number there, and that's going to make it not a direct variation. Okay, well, let's stop right here for right now. The video is going to stop in just a second, and maybe practice that later in your packet.